So my name is Kevin Cleary. I'm the Regional Sales Manager on the East Coast for SCS, Static Control Solutions, and today we're going to troubleshoot a work surface mat that is coupled with a constant monitor. So a lot of people will get a constant monitor and add it to their workbench, and they have trouble with intermittent alarms, and they're just not sure 100% whether it's their mat, their snap, their wire. So we're going to step through some of that today. So real quick, like the standards that call out the ranges for ESD work surfaces is TR53-2018 is the test method that we'll cover today, and then ANSI ESD 2020-2014 4.1 is the section that covers work surfaces as well, and requires the range or states the range of requirement as being between 10.6, 1 times 10 to the 6th, and less than 1 times 10 to the 9th. So that's the range that we're looking for. There's two ways to test. One is resistance to ground, so that's what we'll do first. That's what's called out in TR53. So we'll take one 5-pound electrode and place it in the center of the mat, and then we'll take our ground lead and go to a grounding source on our workbench, test that, and we're looking for resistance to ground, RTG, of less than 10.9. So we have 1.90 times 10 to the 6th, so we're good on our RTG ground. Providing that that's good, the next step would be to go snap to snap. So on a monitored mat, you have 2 snap locations. One snap will connect to the actual monitor itself. The other snap will connect to a earth ground source or factory ground source. So when we test that, we're testing point to point. Again, we want to be less than 10.9, and with the point to point, we are 8.11 times 10 to the 4th. And I'll explain that reading here in 1 second. So it's certainly less than 10 to the 9th. And the reason we're getting 10 to the 4th is because of the conductive layer on the bottom of this mat. So those snaps are making great contact with this conductive layer, and we'll talk about that shortly. So the next step would be to test the actual top to top. So this test, again, is looking for less than 10.9, a range between 10.6 and 10.9. And so top to top, we're going to be about 12 inches apart. Again, we have 2 5-pound electrodes, and then we'll run that test. So we want to confirm the dissipative range of the work surface mat. Dissipative range is important, so that way it releases the energy of any energized component at a controllable rate. It's certainly preferred by the standard to be dissipative versus conductive on the top. So we are 3.18 times 10 to the 6th, which is a extremely good reading. So our top to top is good on the dissipative surface. Again, we'll flip it over. This mat has a conductive bottom. When installing constant monitors, it's important to have a conductive layer. So it could be the bottom layer of the mat being conductive, or it could be a center scrim on a 3-layer mat. So this is a 2-layer with a bottom conductive range, and the 3-layer, oh yeah, I may want to plug it in. So let's insert our leads. And now we get a true top to top on the conductive bottom. So 5.43 times 10 to the 3rd, anything less than 10.4 is conductive. So we have a real nice conductive reading on the bottom side of our workstation mat. So with that being confirmed, now we know that all the features of the mat itself are in check. And the only thing left, we've confirmed that our snaps have a good continuity. So the only thing left is the actual wire itself to ground. So what we want to do is we'll come over and test the snap itself to earth ground. So what we'll have to do here is we'll connect to the snap on my on my setup here. I have a dome snap, so we'll grab a connection here. And then the ring terminal on the other end, it could be free, or in this case, I have it connected to my outlet. So hopefully you can see that. So again, we're 1 times 10 to the third. So we have, you know, if it had a 1 megohm resistor in it, or any type of resistance in this cable, it would have been a 1 times 10 to the 6th reading. So the important feature here is that this connection to ground should be a straight connection to earth ground. So no resistor, no diode, nothing to get in the way of that complete path of resistance. So it's doing a system check on as far as the total surface resistance, and everything we had today is going to be set up and in range, and we should have no issues with the constant monitor or intermittent alarms at that point. So all those features are important. It certainly is a total system check. So you want to go through step by step. A lot of these are called out in the user guide. If you're using a SCS monitor, you can certainly see the details of what the resistance ranges should be, and the fact that there should be no resistor or diode in your earth ground snap. So hopefully that helped out a lot today. If you have any questions at all, we're able to do this troubleshooting virtually, or we can do it in person with our manufacturer's reps that are in the area. So we hope you found it helpful. Have a good evening.